Welcome to the session on Converting ER Model to Relational Schema, Part 1. The prerequisites for this session are Basics of Database Management Systems, Relational Data Models, and ER Modeling. Knowledge of these topics will help you to better understand the concepts. This session will take you through the process of converting strong and weak entities into a relational model. Let us begin with the conversion of strong or regular entity. The conversions of regular entities require that each regular entity in the ER model be converted to a table in the relational model. As for its attributes, all single-valued attributes are simply converted to columns. All composite attributes, however, are broken down to their constituent single-valued attributes and then converted. And all multi-valued attributes are stored in a separate table using the primary key reference. The key attribute is modeled as a primary key. Finally, the general practice is that all derived attributes are simply ignored in the relational model. Consider the strong entity, employee, with attributes employee ID, employee name, date of joining, and years of service. If we were to convert this into a relational model, the entity employee is modeled to the table employee. The key attributes of the entity, employee ID, is modeled as the primary key of the table. Attributes, employee name, and date of joining are modeled into the respective columns. Now the attribute, years of service, can be calculated from the value in the attribute, date of joining. Therefore, the attribute, years of service, is ignored in the relational model. Thus, the entity, employee, is represented as a table with three columns: employee ID, employee name, and date of joining in the relational model. Let's take a look at another example of a strong entity, customer. Consider that the entity customer has a key attribute, customer ID, a single-valued attribute, customer name, a composite attribute, address, and a multi-valued attribute, contact number. As we have seen in the previous example, translation to relational model requires that the entity customer be changed to a table, key attribute customer ID be its primary key, and the single-valued attribute customer name be converted to a column. Address is a composite attribute formed by combining attributes street and city. In the relational model, address will be broken into its constituent two columns, street and city. Finally, the multi-valued attribute, contact number, will be stored in a separate table. Let's name the additional table customer contact. The table customer contact has two columns, one for the multi-valued attribute and another for the primary key column of customer to enable foreign reference. Thus, the entity customer is represented as two tables, table customer and the table customer contact, with the attribute customer ID enabling foreign key reference. Next, let's look at the rules for converting weak entity into relational model. Weak entities are converted much in the same way as strong entities. The only difference in approach for weak entity is that an additional column is added that refers to the primary key of related strong entities table. Consider the entity employee and the related weak entity dependent. As we have seen before, the entity employee will be modeled as a table with 3 columns in this relational model. The weak entity dependent is modeled in the same way to have 2 columns, dependent name and relation. Finally, a new column, employee ID, is added to the dependent table that references the employee table. Now, to ensure that an employee's dependents can be distinguished, employee ID and dependent name will form the composite primary key. Thus, the entity dependent is modeled as the table dependent with columns employee ID, dependent name and relation, with employee ID and dependent name being composite primary keys. To summarize, conversion of strong entities involve modeling an entity into a table, single and composite attributes to columns of the table, and multi-valued attributes to separate tables. As for weak entities, the conversion involves the same set of rules as for the strong entities. The only exception being that the table must have the primary key of the other table on which it depends.